You're most welcome, our candidates 2020. Yes, last time we had corrections, some work to do. And our number one is what happens to light when it falls on a shiny surface? What happens to light when it falls on a shiny surface? What is your response? Yes, remember, this surface is shiny. So what will happen? Light is reflected. So what's our point? Light is reflected. Thank you very much. Number two, give a reason why we are not able to see our image on a sheet of paper like this. You cannot see your image on a sheet of paper. Why? A sheet of paper diffuses, or someone would say, a sheet of paper scatters light rays. Thank you very much. Number three. Okay, number three. There's a diagram there, you seeing it? Identify the type of reflection below. What type of reflection is that one? What did you write? Yes, it is regular reflection. It is regular reflection. Then part B has a question there. Why is the above type of reflection called so? Why are we calling it a regular reflection? Point. Point. A parallel beam of light is reflected as a parallel beam. Okay? Or somebody would say the incident ray is reflected at the same angle as that of the reflected ray. Yes. Yes. That is the most brilliant answer which I want there. The incident ray is reflected at the same angle as that of the reflected ray. Number four, give two importance of reflection of light. Two. First one, what did you write? Reflection of light enables us to see objects. You remember that? That we say that yes, as light is moving, it's reflected, and then some come to our eyes to enable us to see. Then two, reflection of light enables us to see image. Where? On mirrors. So light comes onto a mirror, it's reflected, then you are able to see the image on the mirror. The next, reflection is used in car head lamps. For what? To produce light which covers a wide area or range. So it enables us, those drivers, to see their objects. Our last question. Write one danger of reflection of light. One danger of reflection of light. One danger. Is there any problem? Any danger of reflection of light? Yes. Reflection of light produces bright light that can damage our eyes. Thank you very much for making those corrections. Yes, we want to go to our next lesson. And remember, in this discussion for today, we want to talk more about reflection of light on a surface. Okay? Reflection of light on a surface. So in our discussion, we want to see what happens the light rays as they are moving. What happens the light rays as they are moving, and what will really happen when they meet a surface. More importantly, when the surface is a shining one, what will happen? They will be reflected. You get the point? But as they are reflected, they form angles. They form angles. For example, look there. We have a ray of light which is called the incident ray. Why is it called incident? It is hitting. The word incident means it is coming. So it is called incident ray. So that incident ray, as what is it? They're saying this is a ray of light which strikes a reflecting surface. It strikes a reflecting surface. Strikes. It meets and hits a surface which can reflect it back. Okay, so how can you do that? For example, we have our surface there, which is a reflecting surface. This surface can be a plane mirror painted behind there, and the surface up there which is shining. This is reflecting one, okay? So the ray is there. Super, I sing it? Yes. That ray is striking. It is striking the reflecting surface. So that is the ray we are calling incident ray. Very good. We also have another ray. Okay. What is it called? It's called the normal. The normal. What is this ray? They say this is a line which is perpendicular to the reflecting surface. So something perpendicular, meaning that normal, it forms a 90 degrees somewhere. Mathematics now. Okay? Very good. So can you imagine there? We have our reflecting surface. Okay? And we have our incident ray. Then we are interested in the normal. This normal is represented by imaginary lines, dotted ones. That one there. So that is what we call the normal. Yes, that is the normal. So you're saying this is a line which is perpendicular to the reflecting surface. Very good. Next, we have the reflected ray. The reflected what? Ray. What is it? This is a ray of light which bounces off. You get the point? Bounces off a reflecting surface. So if we have, for example, we have a reflecting surface there. Okay? There is our reflecting surface. Remember, we have talked about the incident ray, the normal. Now we're discussing about the reflected ray. How does it look like? We are saying for it, it bounces off. Meaning, it is moving from this reflecting surface. Okay, we have that is our incident ray. Very good. We have the normal, which is there. So we want to indicate, to show the reflected ray. There it is. You get the point? So remember, we saw our incident rays there. We have the normal, and this is the reflected ray, which you want to label very well on our diagram. Very good. There it is. Thank you very much. Now, as we are discussing this, you must be practicing to draw this, okay? For example, let's go back a bit. Very good. Let's first wrap this work and we redraw it, okay? Good. Not so? Yes, you must practice this, my dear candidates. You must practice this. So we are saying this is a ray of light which bounces off a reflecting surface. So you want our reflecting surface there. Very good. We have the incident ray. Please draw it on the paper. Draw. That is the incident ray. The normal, which is represented in imaginary lines. Please label it. Good. We are interested in the reflected ray, which bounces off. So the arrow must point the other side, meaning it is moving off the reflecting surface. Very good. Okay. Now, something of concern is here. When a light ray strikes a reflecting surface at an angle of 90 degrees, what will happen? It is reflected through the same path. It has to be reflected through the same path. What was that one? That ray which strikes a reflecting surface at an angle of 90 degrees, it has to pass through the same path which brought it. For example, look here. This is our reflecting surface. Okay? Very good. So you notice there are two arrows there, one pointing down to the reflecting surface. What is it representing? It is representing our incident ray. It comes to hit, to strike the reflecting surface. So when it strikes the reflecting surface, but remember it is perpendicular. it is perpendicular. It is hitting, meaning it is making an angle there on the reflecting surface, the angle of 90 degrees. It has to pass through the same pathway to pass through when it was coming. That's what we are calling the reflected ray. Okay? Yes. You must know that point very well. Good. Now, when these rays are hitting this reflecting surface, when these rays are hitting this reflecting surface, what will happen? They have to form some angles. They will form some angles. They will form the angles. Okay? So as they form these angles, we have angles like the angle of incidence. We have angles like angle of reflection. And we also have angles which we are going to see, which are called glancing angles. They are called glancing angles. So here on chalkboard we have what we call angle of incidence. Remember, there is a ray called a ray of incident. So that ray of incident hits a reflecting surface. After hitting a reflecting surface, it is going to form the angle which is called angle of incidence. So what is an angle of incidence? This is the angle. This is the angle between the incident ray and the normal. What have I said? Angle of incidence is the angle between the incident ray and the normal. Okay, for example, look at the illustration there. We have a reflecting surface. Okay, we have the incident ray, very clear there. Incident ray is there. Okay, then we have our normal, very good, that is our normal. Now, we are saying angle of incidence is the angle between the incident ray and the normal. Now, you must use your brain now here, candidates. Where is that angle? Where is it? We have said it must be between the incident ray and the normal. Are you seeing the incident ray? Are you seeing the normal? We are saying angle of incidence must be between those two. There we go. That is what we are calling angle of incidence. Members, I'm saying that one there, that, look at the point there. That is the angle. That is the angle of incidence. It is between the incident ray, and the normal. Thank you very much. Good. We also have, so that angle of incidence is represented with small I, meaning angle of incidence. Okay? Don't confuse these two things. We have incident ray, ending with T. Incident ray and incidence. That's the angle. Okay? Very good. Okay. We also have what they call angle of reflection. I'm very sure now you can guess here the point that it is between the ray which is coming, which is being reflected, which is called ray of reflection. And what? The normal. Yes. Okay, so you're saying this is the angle between the normal and the reflected ray. Are you getting the point? Very good. So if we have our reflecting surface, is there. Very good. And that is the reflected ray. We have it there. The normal comes. This is our normal. We are talking of the angle of reflection. We are saying it must be between the normal and the reflected ray. That ray which bounces off the reflected what? The reflecting surface. Okay? So that is the angle there. Are you seeing it? That is the angle. That is the angle. That is the angle of reflection. Yes. And it is represented by a letter R, small letter R. Good. Yes. Now, we have laws which govern reflection of light. We have laws which govern reflection of light, or which control the reflection of light. The first one is there. First one is there. It says the incident ray, the reflected ray, and the normal at the point of incidence lie on the same plane. Meaning, as the incident ray is coming, it hits the reflecting surface, the normal is there, and the reflected, they meet at a point on that reflecting surface. That point is called point of incidence. And all of them must lie in the same plane. Why are we calling it a plane? Remember, we have been showing what we are calling the reflecting surface is a straight line, a plane. So they all lie on the same plane. That is law number one. The incident ray, the reflected ray, and the normal at the point of incidence lie on the same plane. That is our first law. Our next one is there. What does it say? It says that the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of what? Reflection. Why are we saying that this angle of incidence is equal to the angle of reflection? This is now the point, members. When a light ray is coming, which is that one? The ray of incidence. It hits the reflecting surface, but it has to be reflected at the same angle. Okay? The same angle of reflection. So now we are saying the angle comes, the incident angle of incidence is equal to the angle of what? Reflection. Why are we saying it is the same? Why are we the same? As this ray is coming, it hits the reflecting surface, but it forms the angle which is reflected at the same angle as that of the incident ray. That's the point why they are equal. As traveling, they meet. Now, these laws are very important in our daily life. They are very important in our daily life. They have to. So as we say that these laws of reflection are very useful in our daily life. For example, we are seeing the first one there, the incident ray, the reflected ray, the normal at the point of incidence lie on the same plane. The second is there. The angle of incidence is equal to the angle of reflection. Yes, they are very useful in our daily life. But before we really see how we can apply them in our lives, let's see how we can represent the first law there in the diagram. Okay? Okay, so we have our reflecting surface. There it is. We also have the incident ray hitting the reflecting surface. We have the normal. Very good. Good is there. We have the reflected ray. Very good. Now, we have just said that the incident ray, the normal, and the reflected ray lie on the same plane at the point of incidence. So you notice you also say that the angle of incidence is equal to the angle of reflection. But the point of concern, where these rays are meeting down there on the reflecting surface, is what I've just said that it is called the point of incidence. Where there is letter O, that is our point of what? Incidence. That is our diagram there. Okay? So that's how we represent all the laws in the diagram. The first law we said, angle of incidence is equal to angle of reflection. Then the second law we just said that the incident ray, the normal, and the reflected ray at the point of incidence all lie on the same plane. Very good. So we can continue then and see how we can apply these laws of reflection in life, in other life. More importantly, the second law, which says that yes, the angle of incidence is equal to the angle of reflection. How can we apply them in our life? We need to, some of us are going to be engineers, architects, need to calculate the angles of the building you're going to construct. So we need to have this in our lives. So for example, we have example 1. Okay. We need to apply now the law to find the value of angle W in the diagram. Now you notice where letter W is, that represents the angle of incidence. Where 50 degrees are is what they call the angle of reflection. Now somebody is very much worried. There is no need of calculating here. It is just a matter of applying our law and you get the answer. What is the law? Angle of incidence, okay? Angle of incidence is equal to angle of reflection. So if that is the law and we have the angle of reflection, what do you think is the answer for W? Yes. Therefore, angle W equals to 50. Am I right? No, something's missing. 50 degrees. That is the answer, members. Did I apply too much mathematics? No. Just a matter of applying the law. Angle of incidence is equal to angle of reflection. Therefore, angle W, which is our angle of incidence, it is equal to angle of reflection, which is what? 50 degrees. Thank you. That's our example 1. Example 2. We have our example 2 there. They're saying find the value of the angles below. Angles below. We have the first one there. Okay? So somebody is very much worried because they have changed the diagram upside down. Now, where there is 45 degrees, it is representing the angle of incidence. And the R represent the angle of reflection. And they want us to find the value of that angle, R. So what do? Some simple principle to apply here, the law. So it says, since angle of incidence equals to angle of reflection, okay, what will be our answer? We're just applying the law. Angle of incidence equals to angle of reflection. Therefore, angle R, which is angle of reflection, equals to, what's in the answer? 45. Something missing? 45 degrees. That is our answer. Thank you very much. That is our example 2. Now, before we go in for our example 3, there is something we need to note here, very important. Something we need here to note, very important. Okay? Okay. We have another example 2, part B, okay? Let's first work out that one. We have 70 degrees representing the angle of incidence. We have letter P representing the angle of reflection. They want us to find the angle marked P. So we shall say, since angle of incidence equals to angle of reflection, okay, what will be our answer for angle P? Therefore, angle P equals to 70. Are they eggs? No, 70 degrees. Don't forget that, okay? So that's our example 2. We have part A and part B. Now, in our example 3, there is something very important you need to note before you work out example 3. Okay? So something we need to note here. We have our glassing angle, members, okay? And we said that this is our incident ray. That is the normal, okay? That is the reflected ray. We have the angle of incidence, which is there. We also have the angle of reflection, which is there, okay? There is something very important. You notice down there, near the reflecting surface, there are some angles which are formed there. Okay? Those angles, there are 2. One on the left, one on the side. But we want to just talk about that one there. And also on the other opposite side, there's another angle. I am talking about that angle here, there. How do we call that angle? That is what we call the glassing angle. It's called the glassing angle. Now, many times, they will bring a very complicated number, but yet simple. How? Look at our example 3. We cannot apply, in our example 3 here, we cannot apply the law and we get the answer. Okay? We cannot. So what do we do here? We are going to use the glassing angle. Remember, the glassing angle is down this way, the reflecting surface. For example, here it is 30 degrees. So this is the one we are going to use. So we shall say angle of incidence. This we are going to apply now mathematics. Angle of incidence plus 30 degrees. What does it equal to? it must equal to 90. So meaning from the angle of incidence up to where the 30 there is what? 90 degrees. But we only want to find angle of incidence by the help of what? The glassing angles, which is 30 degrees. So shall say, okay, shall say angle of incidence plus 30 degrees minus 30 degrees equals to 90 degrees minus 30 degrees. What shall we get? So we shall have angle of incidence equal to some mathematics there, side work. 90 minus 30. What do we get there? We have our answer as 60 degrees. Members, what is the difference between this example 3 with other examples? The other examples we are applying the law. Here, the point of concern, we are not applying the law, but we are using the glassing angles to find the angle of concern, which is the angle of incidence. Thank you very much, candidates, for listening to me, and I'm very sure you are going to enjoy my activity. Please get focused and stay safe at home.